Hi everyone, welcome back to my Calculus 1 series. In today's video, we are exploring the derivative of logarithmic functions, a key topic that builds on everything we've learned so far. Logarithmic functions show up everywhere, from solving equations to modeling real-world scenarios. Understanding their derivatives is essential for tackling more advanced problems in calculus. I will guide you through the rules step by step and work through some examples to show how these concepts apply in practice. Let us dive right in. So first of all, let's look at the derivatives of ax and log ax. Now, whenever you are told to differentiate ax, you're always going to end up with the same thing, which is ax, then ln of a. So whenever you have this, a over here is a constant raised to the power an exponent or a variable, you always end up getting this. Also, when you have, if you are told to differentiate log base a to the x, this is always 1 over x ln of a. Now let me briefly explain this part. When you have log base a to the x, you can rewrite this as ln of x, this first, then you divide by ln of a. Remember, a is a constant, so if a is a constant, you can bring it outside, so you can have this ln of a outside multiplying ln of x. So now if you are told to differentiate this, you are going to have 1 over ln of a multiplying the derivative of ln of x, which is, now remember, as we talked before, the derivative of ln of x is just 1 out of x. So if you multiply these two, you end up getting 1 over x ln of a, and that is what we have over here. Now let's look at some examples. If you are told to differentiate 3 exponent x, what do you get? Now remember, this is a constant, so we can use the theorem, right? So it says that we just have to write the same thing, 3 exponent x, then ln of a, but in this case, a is our 3. One thing that you have to remember is always you have to differentiate the exponents right here. So in this case, if we differentiate x, so we end up getting 3x ln of 3, because if we differentiate x, you get 1. Now let's look at the second one. Now instead of x, we have negative x. So remember, always the first thing is to write it, then ln of the constant, which is 3. Then you differentiate the exponent. Now the exponent is negative x, so if we differentiate, it becomes negative 1. Then you multiply by it. So this is just negative 3 to the power of negative x ln of 3. Okay, let's look at a different one. So now we have we have to differentiate 5 to the exponent of sine x. How do we do it? Now remember, with this, we can use the theorem. So now remember, this is our constant, which is a. So we can write everything over here. Then we introduce natural logarithm of our constant. Then we multiply it by the differential of the exponent. So if we differentiate sine of x, you get cosine of x. So your answer is 5 cosine of x sorry, 5 exponent of x cosine of x, then ln of 5. I hope this is clear enough. Okay, let's look at a different question. So now we have dx of sine of 3x. So now how do we solve this? Remember, to solve this, we have to use the chain rule. Let's say we have our y to be equal to sine of 3x. Using the chain rule, we always let what is inside the parenthesis be equal to our u. So we have u to be equal to 3 exponent x. Now, in rewriting our y, we are just replacing this with u. So you're going to have sine of u. Now, u has x in it, so we have to just differentiate u with respect to x. And using the theorem, we have 3x ln of 3. Then y has u in it, so we just have to differentiate y with respect to u. And if we differentiate sine, you get cosine of u, right? So now our differential dy from chain rule, remember dy dx is always equal to dy du multiplying du dx. So in this case, our dy du is cosine of u, and our du dx is 3x ln of 3. So we can just replace this u with what we have over here. So we have cosine of 3 exponent x multiplying 3x ln of 3. So we can just rearrange this. We can have 3x ln of 3 cosine of 3x. And this will be your answer. I hope this is clear enough. Now let's look at the fifth one. If you are being asked to differentiate log base 2 to the x, now remember, as I said before, this is the same thing as saying differentiate ln of x over ln of 2. So in this case, we can just bring ln of 2 outside, then we differentiate ln of x. If we do it that way, ln of x is just 1 over x if we differentiate. So if we multiply the 2, we have x ln of 2. I hope this is clear enough. Okay, now let's move on to some important concepts, the logarithmic differentiation. So sometimes it's very difficult to differentiate a function, especially when you have cumbersome composites of functions, right? That is when we introduce logarithmic differentiation. Now, how do we even use it? Let's consider this. Now, for example, let's say we have let's say you have y equal to this and you're being told to differentiate. Yes, we can use the quotient rule to differentiate, or we can use whatever approach that seems fit, right? Now, using the quotient rule, this is going to be a lot of differentiation to make, but there is a simple approach, which is the logarithmic differentiation. Now, let's look at how it works. Now, whenever you have this, the easy way is, now let's rewrite this. In rewriting the expression, we have to add natural log to both sides. So we have natural log of y, then we have natural log of everything on the right hand side. So we have x squared plus 1 x plus 3 to the exponent of half, and then x minus 1. Now, one thing that you have to note when it comes to logarithm is whenever you have a fraction, it basically means we have to subtract. So whenever you are dividing, you subtract, and whenever you are multiplying, you add. So in this case, we have natural log of y, then we have to write the numerator first, then we subtract the denominator. So remember, we add natural log to the denominator as well. Now that we have this, note that these two are multiplying, so we can separate them by adding. So we can have natural log of y is equal to the natural log of x squared plus 1 plus the natural log of x plus 3 exponent 1 half minus natural log of x minus 1. One property of logarithm is whenever you have an exponent, you can bring the exponent in front of the expression. So this is how it works. Natural log of y is equal to natural log of x squared plus 1. Then we bring the exponent in front. Remember, we are not differentiating, so we don't subtract 1 from the exponent. You just bring it in front and leave it as it is. Then minus natural log of x minus 1. Now, after getting to this part, there is no way to rewrite the expression. So the next step is to differentiate. Now, in differentiating this expression, remember, we have to use the implicit differentiation. Now, if we differentiate ln of y, you get 1 out of y. But note, since y is not x, remember we are differentiating with respect to x. So since y is not x, we have to add dy dx. Now, whenever you are differentiating a logarithmic function, all that you have to do is to first of all differentiate what is inside the parenthesis. So in this case, if we differentiate x squared plus 1, we get 2x. Then we divide by what is inside the parenthesis plus 1 half. In the second term, we do the same thing. If we differentiate x plus 3, you get 1. Then we divide by what is inside the parenthesis. Then next one, the same thing. If we differentiate what is inside, you have 1, and you divide by what is inside. So rewriting this, we can have 2x out of x squared plus 1 plus 1 out of 2x plus 3, then minus 1 out of x minus 1. Remember, we want to find the y dx. So in this case, what we have to do is we have to send 1 over y to the right hand side. And in doing so, we just have to multiply everything by y. So we are going to have dy dx is equal to, just multiply everything on the right hand side by y. So we have x squared plus 1 s plus 3 x minus 1. But note that y was given to you in the question. Now y was given to you to be this. So you can just replace this y with what was given. So your dy dx is now x squared plus 1 x plus 3 raised to the power 1 half out of x minus 1. Then you multiply by the rest, so x squared plus 1 out of 2x plus 3 minus 1 out of x minus 1. And this will be your answer. So if you go through using a different approach, such as the quotient rule, you will end up getting something like this, but it might not look exactly like this. You have to do some simplifications and all that. So the logarithmic differentiation helps us to break it into simpler terms, and it's really good to use. Now let's look at a different question. let's say we have y equal to the cube root of x multiplying x minus 2 over s squared plus 1. Now we have to find dy dx. So first of all, before the first thing always to do is to add natural log, right? But before we do that, we have to rewrite the right hand side first. So we can have y equal to, now in rewriting, remember the cubic root is the same as writing the expression and raising it up to 1/3. So this over here is the same as this, remember that. Now after writing it this way, then we can go ahead to add our natural log to both sides. And remember, as we did in the previous question, whenever you have an exponent, it always comes in front. So we have ln of y equal to 1/3 ln of x minus 2 over s squared plus 1. Now, when you get to this point, we have a fraction. So the next thing to do is to subtract. So we have 1 out of 3. So we have ln of the numerator minus ln of the denominator. So let me copy this right here. Okay, so this is what we have. What is the next step? Remember, these two are multiplying, so we can separate them. So we can have ln of y equal to 1/3. And if we separate, since they are multiplying, we are going to have addition. So ln of x minus 2. Then minus ln of s squared plus 1. Now note, we can't simplify it any further. So the next thing to do is to differentiate both sides. So if we differentiate ln of y, you have 1 over y, then dy dx. And if we differentiate what is on the right, you just have 1/3. If we differentiate ln of x, you just have 1 out of x. If we differentiate this, first of all, differentiate what is inside the parenthesis, you have 1. Then you divide by what is inside. The next one is differentiate what is inside the parenthesis, so you have 2x, and you divide by what is inside, so s squared plus 1. So to find the y dx, you just have to multiply the right hand side by this y. So in this case, we have 1/3 y, then 1 out of x plus 1 out of x minus 2 minus 2x out of s squared plus 1. So our dy dx notes that your y in this case was the cubic root of x multiplying x minus 2 out of s squared plus 1. Then you write everything as it is. So 1 over x plus 1 over x minus 2 minus 2x out of s squared plus 1. I hope this is clear. Okay, let's look at the third question. So in this case, we are differentiating with respect to theta. You can use quotient rule if you want, but the question is just asking us to use logarithmic differentiation. So as we do, always add natural log to both sides. After doing that, since we have a division, you just have to separate everything. So we have this, then minus. Who can tell me what's the next step? When you get to here, what's the next thing to do? Yeah, so you guessed right. So the next thing is, since we have multiplication going on here, remember we have negative here, so we can write ln of theta plus ln of cos theta, which is simply ln of theta plus 5 over here minus ln of theta minus ln of cosine of theta. Now there is no way to rewrite it again, so we go ahead to differentiate. So now if we differentiate ln of y, you have 1 over y, then dy the theta. If we differentiate this, if we differentiate theta, you have 1. If we differentiate 5, you have 0. So over here we just have 1 over theta plus 5. This is 1 over theta. And over here, if we differentiate cosine of theta, remember you have negative sine of theta. Then you divide by cosine of theta. Negative and negative right here will give us positive. So we have positive here. So we have 1 over y dy the theta to be theta plus 5 minus 1 out of theta, and sine theta over cos theta is tan theta, remember. So to find y, we just have to multiply everything. To find y the theta, we have to multiply everything by y. So in this case, we have y multiplying theta plus 5 minus 1 over theta plus tan theta, which is the same as, now y was given to be theta plus 5 theta cosine of theta. So we just have to multiply everything as it is. And this will be your answer. I hope this is clear. Okay, so let's look at a fourth question. So we have this. So how do we differentiate this? We have to find the y dx. So always add natural log to both sides. Now remember, since we have an exponent of x, it comes down. And on the right hand side, since we have two terms multiplying, we can separate them by adding. And we do the same thing. Since we have an exponent, it comes down. Right? So now the next thing to do is we have to differentiate. And to differentiate, we have to use implicit differentiation. Remember, on the left hand side, we have x and ln of y. So differentiating, we have to use a product rule. So for the product rule, remember, we hold the first term in place and we differentiate the second term. So if we differentiate the second term, we have 1 over y dy dx. Then plus, we differentiate the first term. So if we differentiate x, you have 1. Then you multiply it by ln of y. So you have this. On the right hand side, you have 3 multiplying ln of x. If you differentiate ln of x, you have 1 over x. Ln of y, if we differentiate that, you have 1 over y, then dy dx. So basically, you have x over y dy dx plus ln of y. This is equal to 3 over x plus 1 over y dy dx. And remember, to find the y dx, you just have to group like terms. So you can send this one over here, or you can break this one to the right hand side. Any of them works. So I'm going to send 1 over y dy dx to the left hand side. So if I do that, since it is positive on the right hand side, if it's cross it becomes negative. Then I have 3 over x. If I send ln of y to the right hand side, it also becomes negative over here. So all that I have to do is to factorize dy dx out, bring it out. And then over here I just have x over y minus 1 over y. And this is 3 out of x minus ln of y. So I have dy dx. Remember, I can simplify this further. Since they both have the same denominator, I can have y here and then x minus 1. And this is equal to 3 over x minus ln of y. So to find the y dx, all that I have to do is to divide everything by x minus 1 over y. So I have 3 over x minus ln of y. Now, instead of dividing by x minus 1 over y, you can find the reciprocal of it. So this is just multiplying everything by y over x minus 1. You just turn this upside down. I hope this is clear. So the next thing to do is to just multiply. So if you multiply 3 over x by this, you end up getting 3y over x minus 1. And if you multiply ln of y by it, you have y ln of y out of x minus 1. So we can simplify further. When you have this and this, if you find the LCD will be x minus 1. So this goes into this, you have 1, and you multiply it by the numerator, so you have 3y. If this goes into this, you just have x left, so you multiply it by the numerator, so you have xy ln of y. So your dy dx is equal to this. I hope this makes sense and it's clear enough. Let's look at another question. We have x is equal to y exponent xy. So we do the same thing, ln of x, ln of y, xy. Then using the properties of logarithm, the exponent comes down, so you have this. Now we have to differentiate on both sides, right? Remember, if you are differentiating this right here, it's kind of tedious. So what you have to do is you use product rule since you are multiplying. Now when you have xy ln of y, we can use a product rule that says we have uv plus vu plus uv prime, right? So now remember, which one do we choose as u and which one do we choose as v? So first of all, one can choose u to be xy and choose v to be ln of y. Someone also can choose u to be x and v to be y ln of y. It's all the same thing. So now choosing u to be this and v to be this, if you find u prime, you have to use implicit differentiation. So in this case, remember, we hold x in place, we differentiate y, we have dy dx plus, you differentiate x, you get 1, you multiply it by this y, you have just y here, and v prime is just 1 over y dy dx. So combining them using this, we have u, which is xy, multiplying v prime, which is just 1 over y dy dx, plus v, which is ln of y, multiplying x dy dx plus y. Now over here you can see that this y will cancel this y, so we have just x dy dx plus, now we can distribute ln y to this 2, so we just have x ln of y dy dx plus y ln of y. So if we differentiate this right hand side, this is what we get. So we can come back to over here. If we differentiate ln of x, we have this, and if we differentiate the right hand side, we get this right here. So now the next thing to do is to group all the like terms, the one with the y dx. So since we have the y dx here, we can just leave it there and just send this to the left hand side. So if we do that, it becomes negative. So we have this. So we have 1 over x minus y ln of y. Then if we bring the y dx out, we just have x plus x ln of y. So to find the y ds, we just have to divide through by x plus x ln y. So we have the y dx is equal to the left hand side, which is this, then dividing x plus x ln of y. Remember, in the numerator, this is always over 1. So if you find the LCD, you just have x over here, then 1 minus xy ln of y, then everything dividing, we have dividing x plus this. So if we find the reciprocal, I'm going to have this. So now if we multiply the two, our final answer is going to be the y dx is 1 minus xy ln of y in the numerator. In the denominator, we have x multiplying x plus x ln of y. And this is your answer. So you just have to be careful when differentiating, and you have to use what we've learned so far to help you differentiate it easily. Now let's look at the last set of questions. Okay, before we do that, let's look at this. We have to use logarithmic differentiation. So natural log of y, natural log of sine of x to the x, natural log of y, x comes down, so you have ln, then you have sine of x. So if you differentiate the left hand side, you have 1 over y dy dx. If we differentiate the right hand side, this is product rule. We have two functions, right? So hold the first one in place, which is just x, differentiate the other term, this. Now if we are differentiating ln of sine x, remember, you differentiate what is inside the parentheses, you get cosine of x. Then you divide by what is inside, so you have sine x, then plus, now we differentiate this, we have 1, then we have just ln of sine x left. We are using the product rule, which is f of g prime plus g of f prime. So in this case, we have 1 over y dy dx. Remember, what is cos over sine? Cos over sine is just cotangent, right? So we have cot x plus ln of sine x. So to find dy dx, we just have to multiply the right hand side by y. Okay, so our dy dx is, now y was giving us sine of x to the exponent of x, then we have x cotangent of x plus ln of sine x, and this will be your answer. So I hope this explains how to use the log differentiation. Now let's look at the next set of questions. Okay, so we have to differentiate this with respect to x. First of all, let's rewrite the expression. So if you have log base 4 of x, the same as ln of x dividing ln of 4. The next one is the same as ln of s squared dividing ln of 4. Now, in differentiating, we can have the left hand side is going to be dy dx. The right hand side, for the first time, we are just going to have 1 over x ln of 4. In the right hand side, for the second term, we are just going to have 2x, remember, out of s squared ln of 4. So this just simplifies to 1 over x ln of 4 plus, so this x is going to cancel one of the x's here, so we just have 2 over x ln of 4. Now, since the denominators are the same, we can just add the numerators. So we have this, and this is our answer. Let's look at the last one. Now with this question, we do the same thing, right? Let's rewrite. We have ln of e to the x over ln of 5. But remember, one thing that you have to notice, whenever ln and exponential meet, they are inverses of each other, so it cancels out. So ln of e to the x is the same as x. So ln will cancel e, so you just have x left. So another example is, if for instance you have ln of e to the power of 2, this is just 2. Or in other ways, you can also say ln to the e of x is the same as, remember, this is an exponent, you can bring this down, so you have this. Now, natural log of e is 1, so you multiply x by 1, this is just x. I hope this explains it as well. So we can have y equal to x out of ln of 5. So to differentiate, we have dy dx is equal to, we can bring the constant outside, which is this, then we differentiate this. So the y, the x is just 1 over ln of 5. Remember, if we differentiate this, you have 1. So if you multiply it by 8, it doesn't change anything. So this is our answer. I hope this really explains the concept of logarithmic differentiation. That is it for today's lesson on the derivatives of logarithmic functions. I hope this video made the process clearer and easier to understand. If you found this helpful, please like and subscribe to support the channel and stay tuned for more videos in this Calculus 1 series. Feel free to share your thoughts or questions in the comments. I would love to help. Thanks for watching, and I'll see you next time.